Hello, my name is Damir Shamanov. Wait, let me turn on my video. Sorry for that. Yeah, that should do the job. All right, is all good? You can see me and you can see the presentation. All right, so my name is Damir Shamanov. I am an author of the Move book. It was the first piece of documentation on Move back in 2020. I started working with Move in the end of 2019, I think. As an early enthusiast, I've been a part of the company that's called DeFinance, and before, now they're called Quantum Network, and you probably heard of them if you're familiar with Move. So this was my team, and now I'm working in Sui with Sam, who's always been a presenter and also participating in the community, hopefully a little bit. So today we're gonna talk not strictly about Sui and not strictly about Move, but more like basic Move, and expect that some of you have some experience and knowledge about like how Move works, and I'm gonna show you something that we have similar to interfaces. I know that this feature has been in the wish list of many people, and I'm going to show you how we can preserve a type while allowing people to have custom implementations of this type in their modules. So first we'll go through two patterns, which is witness and capability. These two patterns are a base for the authorization and actually proving that you can do something on the type level statically or on the object level dynamically. And then we'll go through a thought experiment where we'll build a collectible type. We can treat it as an NFT standard or like a base for an NFT standard. We'll see when we get there. And then we'll try to map this results to Sui Storage model. I'll give you a quick overview of how we do storage, and I'll show you a couple more examples of how this pattern could be used elsewhere. So let's start with defining the base terms. Usually, and like most of the frameworks know this thing that if we need to authorize something statically, and if we can prove that we own a type, we use a witnessed pattern. It's on the left. When we create a coin, it was in the DM framework. We have it in Sui. I'm pretty sure there is the same and similar approach in Aptos and Starcoin and 0L. So basically, we have an empty struct which has a type, which has a droppability, and when we create a coin, we pass it there just so we prove that we are the creators, that we are the owners of the module, and through creation of type, we confirm that we own it. And so another pattern that is available in Move due to borrow checker implementation, that we can pass something by reference. And so like if there is an object called admin capability and the function requires it, no one else can call it. So admin capability is a capability pattern which allows you to dynamically authorize your action by passing it explicitly into the function while not allowing anyone else to call it. So this was the base, and now we'll get to the collectible type experiment. So it is a code that I used. We had in one of our PRs and suggestions for the NFT standard implementation, but it never got through. But it still has and contains some very new, very fancy experiments on the type level and what we can do in Move. And so for that, we need to define a collectible T type, where T will be a metadata or any object that actually has store and drop abilities. And we'll set the few ground rules so that only manager can create new collectibles and will authorize this action via capability pattern. We, on the base level, we will limit how many collectibles of a single type, like of one collection, can be created. For example, if we said that we can only create 100, then we need to force the creator to have only, maximum mint 100 NFTs or collectibles. And then we also want to allow any developer, while still preserving the collectible type, to be able to define custom behavior for this type and custom implementation for this type. That is the most important part in this experiment. And so defining the base. It's a very simple object. We can call it whatever we want. It is also a common pattern. We define generic parameter t, and t goes into the info field, and we just store some like custom user-defined type inside our collectible type, while also like keeping the unique number of the item in the collection, and also addition is how many items will be in this collection. To have a manager authorization, we'll use a capability pattern. So like we'll create a collection manager cap, also of type T, so we can like match the collection manager cap and the collectible type. And so this T is the same everywhere in this implementation. But like the collection manager cap acts as a treasury cap for coins, for example, when you specify like total supply and max supply, we just track this method parameters for the collection, and we enforce some ground rules, such as that only like 10 or 100 or 1,000 collectibles can be created, but no more. So to start the collection, we still require the witness pattern. And as you can see, and it's important to keep track of that, the T here is not used. So like the T parameter is ignored. Is a typical drop behavior of a witness when we create a collection manager cap, which does not contain the T. And so, yeah, some summary here. Witness makes sure that collection has a unique type signature and it's type T, and we statically authorize it by proving the ownership of a type. If there is no way for you to like create this instance of a T, then you can't have items of the T, and so like whoever owns the T controls the collectibles of this type. And so once collection manager cap T is defined, it allows us to create new collectibles. Usually after defining structs, we define view functions for the type that we defined. And so like for simplicity's sake, we just have unique number, the base parameter, we can access info, immutably borrow, but we can also immutably borrow and get an IDs. These are all convenience functions. It's not important for the sake of this experiment. And so when we mint something, we need to supply the metadata. We need to have the info field inside. And also, we need to pass a collection manager of a witness, actually. This acts as a witness, and a collection manager cap acts as a capability. So like no one can call this function but the owner and the creator of the collection who also owns the type. So this method is secure on both fronts and uses both methods of authorization that we have in Move. Keep in mind that info here goes into a collectible, so we actually use this thing, this T. So when we pass any object, actually, of type T, if we constrain it, we use it as a witness. And so it does not necessarily have to have droppability, and it doesn't have to be empty. So like whenever you create a container for a generic type T and you pass this T, what you actually do is you use this T as a witness. So witness doesn't have to be an empty struct. And so the resulting struct can only be created if this T is applied. So like most of the implementations that have this, I'm sorry, yes, this presentation is very abstract, my team, but this is how it is. So when you pass a T, you always authorize it with a type. and this T becomes a witness. So if we like take 2 steps back and look like at differences in these functions, when we create the collection, we pass a metadata for our collectible, but we don't use it. But when we mint a collectible, we need to supply like a name and URL in this T, so it's like our NFT metadata, and we actually use it. And since there is this like slight tweak in how we use it, like it gets discarded when we create a collection, but we still create the NFT metadata. And when we mint, we actually mint real metadata. We can see, for example, I mean, let's just go for implementation, and you'll have some more details. So we'll define a default. I just call it like default standard for simple standard for NFTs, which has name and URL. And so when we mint it, we just create this new name. I mean, we create new default metadata from name and URL, and we call a collectible mint. We kind of everything works. But to make the same metadata for the method create collection, we need to also create this metadata, but it won't be used. And for this, I have come up with I call it a null object. So you can use an empty object with fields. I mean, not empty, but like meaningless object, like a dummy object with fields as a witness. So you preserve a type when you have a metadata and when you actually use it, and you just drop it, and you can use a witness pattern. So like we have in create collection, here we supply the null object instead of actually like somehow using this metadata. So yes, so again, we created an object. At one place, we used it as a witness. In another place, we used it as a field and something meaningful. And this is a trick that can actually help you have the same type between 2 objects, one of which requires something, and another one just needs to be created with witness struct. Little bit of summary. So capabilities provide dynamic authorization. What it means is that I can pass capability to someone, and this object authorizes some action, but it exists in dynamic space, and it can be like wrapped, mutated, its access is controlled later on. While witness provides a static type level authorization, and the use of a witness, if it doesn't have store, has to be defined in the module, and so we can like statically check that this module actually creates one witness, and I call it static type level authorization. So capability also can be created through a witness, and so capability now mixes 2 things in it. It can be used to create this witness T types while also being in capability. So like just saying we can have a full mix of authorization types and move. Yes, and lastly, witness is not necessarily a struct without fields. So we can have witnesses with fields which can have some meaning if needed. So we can just fill it with dummy values. For example, like if you have a name, you can supply an empty name. If you have a URL, empty URL. If there is a vector of tags, just send an empty vector. It's going to be like a dummy object, which will behave as a witness, but like when filled with data, it will actually be something meaningful, and it will be metadata. So in Sui, we have, I mean, you probably heard about us, and we have a slightly different storage model where we don't have borrow global, we don't have borrow global mute, nor do we have move from or move to functions. Instead, we have 3 types of objects, and we have 3 built-in functions which define how this object is stored and how it exists on the platform. So we have shared objects. Shared objects are objects that are placed for everyone to have access to, and everyone can access it as a mutable version. But no one can move it. So once it has a location, everyone can access it by its ID, including mutably access if the module defines the mutability logic for it. So like all access control checks and like who can modify it, how they can modify it, everything is controlled by the module. We also have owned objects or single writer objects. So this is an object to which only I or you have access to if you own it or if I own it. And so this is an object which is owned by me, and so I can do whatever I want with it, and you cannot access it. And lastly, we have a frozen or an immutable object. It's an object constant that is placed on the chain. So it becomes immutable, no one can edit it, but people can reference it as a source of data. So, like small summary, yes, single owner objects, only owner can access them, only owner can modify them, and he can move it somewhere else. He can share it, he can freeze it, or he can pass it to someone else. So, for example, coin, like I own a coin, I send a coin, then they send the coin, and whatever happens with the coin. But if we have a marketplace or a liquidity pool, it's going to be a shared object because many people need to have access at the same time. And like when you place a marketplace, you expect people to actually have access to it so they can buy items or list their items there. Immutable or frozen objects are tricky ones because it's really hard to find an application for an object that is just placed on chain and is not used because you can't mutate it, you can't change it. And so with immutable objects, I think the best way to use them is for configuration, or if you have, if you need to supply an on-chain proof that your module actually is supposed to be like URL of your D app. So like I create a game, I place an object on chain saying like the URL of my game is like CryptoKitties or capybaras. And so this way I can prove to people off chain that I actually created this configuration. And the same thing can be used like on chain. You can reference this object once if you know its address. So we're getting back to collectible. As I said, every object on Sui can exist in three states. It can be transferred, which means it is owned. It can be shared. Everyone can have access to it, and it can be frozen. It becomes immutable. And for the collectible, we can witness protect which of these methods will be implemented. So for example, for default collectible, we only allow single owner object, single ownership, or we only allow it owned. And so we define custom transfer function in our collectible and we authorize it with witness. If you look again here, every of these methods is available for implementation, but is not implemented. So my default collectible will only have transfer function. So now I have access to this functionality. I can define the storage for my custom default standard for a collectible. For example, if we were implementing a different collectible, we could use a shared object. And so this is an example from a different implementation, which I call tricky, where instead of sending it to someone, you actually share it and you specify an owner of this object, and you have a logic who can interact with the shared object and in which way. And so here is, I hope that you can see this because there is a lot of information. On the left side of the screen, you can see the regulated coin implementation. Regulated coin every method of a regulated coin requires a witness. So if we wanted to implement regulated coin, for example, what regulated coins we have? For example, USDC, like centralized regulated coin, we could define what methods we would allow and under which circumstances, while preserving the type regulated coin USDC in this example. On the right side, you see just coin. So basically, it has the similar, or in some places, absolutely the same methods, but they're available to everyone from the coin module. So by having the common base between coin and regulated coin, one is free and already implemented for you, but another one can be implemented in different ways. So like USDC can allow, for example, I mean, in our thought experiment, that transfers are forbidden. You can transfer your asset, while in coin, everyone can transfer a coin. But it is important and a cool feature, really cool feature in witness-based implementations where every method or half of the methods or some portion of the methods it requires a witness, is that you can give default built-in functionality while leaving the latter to implementers. And I usually call it a witness interface. Well, it's not technically an interface, it's more like an abstract class, of course. So what we have here, we reuse the base type. So if we had a collectible, we know that this is a collectible, even though it has a custom implementation. If we had a regulated coin example, we know that this is a regulated coin. And so we can create a storage for regulated coins, but we don't know the implementation details of them, or we don't know the implementation details of a collectible. It is good for discoverability in wallets in Explorer if you have like a special standard library type for regulated coin or for a collectible. You know how to display it, you know how to treat their metadata, and you can also enforce the base rules for the base type, while leaving the rest of the implementation, I mean, the rest of the functions up to implementers, which is one of the tricks that we have in our move tricks arsenal. So we can define base properties. Everything else is up to implementation. We can define a standard and a standard type, which will have some behavior on which people can build on top again. Maybe it's not, that's like usability tweak. It's not too convenient to use like collectible, then shared. If someone build a standard on top of that, and then T, and it could be like collectible, shared, my NFT, and then T again. Maybe it's not that convenient, but it solves a very specific problem where you still preserve the base type, and you know that every collectible can be created only like in 100 or X times. I mean, minted. Sorry for that. So you can define these ground policies for the base type. And then the second standard that's built on top, for example, shared or default, can define their base ground rules for this specific standard. And lastly, on Sui, since you have access to the transfer functions and like transfer or share object or freeze object, you also allow users to implement any storage model for these objects. So it's like as if you gave them mutable reference to borrow mute or borrow global, and you allowed them to store their data however they want. And so the base module, which would only define the base type and no storage implementation at all. Lastly, I have another example, which I call subscription. Subscription is a module that is half implemented for you, but like additional details are left to other people. So subscription is like you buy 10 passes to Subway, or you buy 1,000 requests to API. And so subscription has like 1,000 uses or some U64 uses. And a single use is going to be our hot potato, which you take from subscription, you pass into a function, you authorize this action, then you have to repurchase subscription again once it's like empty, once it's done. And we can define the base functionality for the subscription, which will be available to everyone, which is like we can see the number of users, we can use a pass issuing a hot potato, and we can destroy subscription if we don't need it. So this functionality is available to everyone out of the box. So subscription is like already usable, kind of. But like, if I'm building a marketplace with a special, I don't know, promo subscription, like you get 1,000 discount codes or something like that, you define how the subscription is created through the witness implementation. You can also implement a function how to top up, how to add more users, and how to like prolong your subscription. The application defines what is a confirmed use. So in this confirmed use function, we can inject it into some function and say that if this function was called and subscription was supplied, then we confirm the use of the subscription, and it's left up to implementers. And lastly, the Sui feature, we can define whether the subscription can be transferred to a different account, because by default, it cannot. So subscription is, I mean, might be a little tricky to understand, especially without the context, but I believe that's also like, I mean, it shows one side where we have pre-implemented methods and the rest is left to implementers, to actual applications who will define how this subscription will be used in their applications. Questions? I don't know if there's like, is there time for questions? I think it's time.
Okay, if the listener have any questions, I will set it to the WeChat later. Okay, thanks. Thanks, Samuel.
Awesome.
Awesome.
Yes, there's a couple of things, which is example.sui.io or docs.sui.io or just sui.io, where you can learn about our project and you can see the actual Move code samples there, especially on the first link. That's our book dedicated to Move examples, Sui Move examples. So, the GitHub URL is github.com, Misten Labs. Sweet. That's our GitHub.
Very good. Thanks.
Thank you so much for having me. It's a pleasure to speak to a new audience, especially.
There is a question. Are you the author of the VS Code plugin, Moves syntax?
Yes, I am the author of the Move syntax in VS Code, and thanks to folks from Move, I think it's called Move Down. This is also the syntax of GitHub. So yeah, I mean, I've implemented both. This is for GitHub and for VS Code, and Move Analyzer also uses the VS Code one.
The next question is, when will Sui have mainnet launched?
We don't have a specific date. It'll probably happen next year, but we're still in the process of actually estimating when the actual launch will happen.